Now that we've discussed the major ECG waves, intervals, and segments seen on an individual lead, now we can review how heart rate is easily determined by understanding the timing between different waves. So in the broad perspective, an ECG is really just a graph of voltage changes over time. Voltage is displayed on the y-axis as millivolts, and time is displayed on the x-axis as is measured in milliseconds. Here I've taken a sheet of ECG paper and have drawn x and y axes to give you a perspective on how this is arranged. Also, I'm blowing up a large box so we can see more clearly how ECGs are measured and timed. So remember that the y-axis is a measure of voltage. Each small box has a height representing 0.1 millivolts. And that means that one big box is 0.5 millivolts. On the x-axis, the width of each small box represents 40 milliseconds. And because there are 5 small boxes in every large box, a large box is equal to 200 milliseconds, or about a fifth of a second. If you have a recurring event, like a recurring P wave or a QRS wave in sinus rhythm, then you can count the number of boxes between 2 P waves or 2 QRS waves to determine the heart rate. So for example, if an event recurs every 5 large boxes, then it occurs once per second. This is also called 1 hertz. If an event occurs more rapidly, say once every large box, then this would be 300 beats per minute. The way we calculate the heart rate is to take 300 and divide this by the number of large boxes. So 300 divided by 1 large box equals 300 beats per minute. And we can continue this easy calculation on down the line. A recurring event over 2 large boxes is 300 divided by 2, or 150 beats per minute. 3 large boxes is 100 beats per minute. 4 is 75 beats per minute. And 5 is 60 beats per minute. From this formula, you can extrapolate other rates as needed.